Let's take a look at the first example. In the first example, they are telling me that x is equal to 2y minus 6. So I'm going to take that value or that expression for x and go substitute it into the other equation. Hence the substitution method. So when I do that, I will have this bottom equation that says 3, but where that x is, I'm going to put 2y minus 6, then plus 2y is equal to negative 10. So it says 3, put that expression in for x, plus 2y equals negative 10. Then that just gives me a nice equation to solve. You're going to distribute your 3, of course, and when you do, you'll have 6y minus 18 plus 2y is equal to negative 10. Collect your like terms. 6y's plus 2y's is 8y minus 18 is equal to negative 10. Add your 18 over, so you have 8y is equal to negative 10 plus 18, which is 8. Divide by your 8, and y is equal to 1. Now that I have the first answer, I'm going to take that answer, what y is, and go substitute it back into one of the 2 original equations wherever there's a y. It does not matter which one you substitute into, but I think it's easier if you go to the top one, because after all, we're trying to find out what x is equal to. So I will say x equals 2, but where that y is, I'll put 1 minus 6. And I get x equals 2 minus 6, which is negative 4. Now, some teachers like your answers written as an ordered pair, so certainly you could also write that as negative 4, 1, remembering that every ordered pair is x and then y. One of the nice things about these types of problems is that you can check your answer. So don't forget to take advantage of that, especially on quizzes and tests. So what you would do is you take the x and the y that you got, and you go back and put them into both original equations and see that they're true statements. So I would say negative 4 equals 2 times 1 minus 6. And that's true. Here I would say 3 times negative 4 plus 2 times 1 equals, and sure enough, it equals negative 10. Okay, let's take a look at the second example. On the second example, they are telling us again that y is equal, or this time they actually said negative y is equal. Here's the deal though, when you're plugging in, you don't plug in negative y, you have to plug in positive y. So therefore, I'm going to need to divide every single person by negative 1 so that I have y equals negative over negative is positive 2x plus 2. Now I can take this expression for y and go substitute it into the other equation. So doing so will give me 2x plus 4, but where that y is, you're going to say 2x plus 2 is equal to 8. Now solve your equation, which I'll distribute that 4 in a second. So 2x plus 4 times 2 is 8x, plus 4 times 2 is 8, is equal to 8. Collect your like terms. 2x plus 8x is 10x plus 8 is equal to 8. Subtract your 8, and you get 10x equals 0. Sometimes this equation kind of confuses students, but just stick with the plan and know that you're dividing by 10 just like you would if there were any other number over there that wasn't a 0. And so x equals 0 divided by anything is just 0. Now I'm going to go put that 0 back in to one of the original equations. I can put it here, here, or there, any place. I'm going to go to that bottom place where it says y equals, because after all, we want y. So y equals 2, but where that x is, I'll put 0 plus 2. So y equals 0 plus 2, which is 2. Then writing that as an ordered pair would be x, comma, y. Okay, let's take a look at example 3. Notice in example 3, it's different than the two previous examples. In the two previous examples, they have just from the beginning pretty much flat out told us y is this stuff. Or in the first one, they said x is this stuff. So you knew what you were going to go substitute into the other equation. But on this one, you have to, for yourself, think, what am I going to put into the other equation? I suggest that you go through every single variable and look to see who is the easiest one to get a hold of. This y right here is all by itself, so it's the easiest one to get a hold of. So therefore, I'm going to take this 2y plus x equals -1, and like we said, that y is by itself and easy to get a hold of, so subtract 2x from both sides. That tells me that y equals, and you can either say -1 minus 2x, or you can say -2x minus 1. The main thing is to keep the sign with the variable. In other words, keep that face with that body. I'm going to say -2x minus 1. Now you're going to take that y and go substitute it right there for y. This is the equation that you used. It's very important that you substitute it into the one you didn't use. So I will say -4x plus 6. But where that y is, I'm going to put in the expression -2x minus 1 is equal to 6. So -4x, distribute your 6 through, minus 12x, and 6 times -1 is -6 equals 6. Collect your like terms. So -4 and -12 is -16x. Equals. This right here is a minus 6, and I'm going to need to plus 6 over there. So 6 plus 6 is 12. I'm going to divide by -16. Looks like we're going to get a fraction this time. So 12 over -16, you're just going to reduce. I see that 4 goes into 12 3 times, and 4 goes into 16 4 times. So -3/4, or certainly you could do the decimal of 0.75 if you like that better. Now I'm going to take that and I'm going to go substitute it back in for this x. You could have gone to this one. It would have been okay, but I'm headed over there. So then I will say y equals -2. But where that x is, I'm going to say -3/4 minus 1. So be careful with your fractions here. Either be really careful or use your calculator. First of all, negative times negative is going to be a positive. And 2 times -3/4 is a positive 3/2, or 1.5. Mentally, if you need to, you could think, well, 2 goes into 4 2 times, and then you can see it's 3/2. And then minus 1, so y equals 1.5 minus 1, which is 1/2. And so then you're going to have your ordered pair of x, comma, y, and it will be negative 3/4 and 1/2. Don't forget, we said you can check these answers. You could say 2 times your x value plus your y value equals negative 1 is what you get. Negative 4 times negative 3/4 plus 6 times 1/2 equals, and sure enough, it equals 6. All right, let's take a look at number 4. If you'd like to, you could pause the video, try the problem on your own, and then come back and see if it checks. So once again, we need to look through the problem, and we need to decide who we want to get a hold of in order to substitute into the other equation. Looking through everything, this y right here looks to be the easiest one to get a hold of. So I will say negative 2x plus y is equal to 3. I'm going to add that 2x over, so plus that 2x over, and y is equal to 2x plus 3. So I'm going to take that y and go substitute it into the bottom equation. Once again, you used the top equation, so you substitute it into the bottom equation. So I will have negative 4x plus 2, but where the y is, I'm going to put that whole expression, which says 2x plus 3 is equal to 6. Negative 4x plus, distribute, 4x plus 6 equals 6. Collect your like terms, and I can see those actually cancel. And I get 6 equals 6. All the variables are gone, but I'm left with a true statement. 6 does equal 6. When this happens, that means that you have infinitely many solutions. If for some reason you got a false statement, there would have been no solution to that problem. Okay, let's take a look at this last one. And once again, if you'd like to, pause the video, try it on your own, and see how you do. So we've got a game plan of looking through here and seeing who looks like the easiest one to get a hold of. And I can see that this x is the closest thing to being by itself. So therefore, I've got negative x plus 4y is equal to 24. I'm going to subtract the negative 4y. So that negative x, make sure you bring your face down with your body, negative x equals, same thing over here, negative 4y, positive 24. Keeping your signs with your variables and expressions. I can't substitute negative x, I have to substitute positive x. So therefore, I'll be dividing every one by negative 1 to give me positive x equals positive 4y minus 24. Now, this is the equation that I used, so therefore I used this one, so I'm going to take this expression and go put it into the other equation. So 3, but where the x is, I will say 4y minus 24 plus 6y is equal to 18. Distribute, I'll get 12y, and 3 times negative 24 is negative 72, plus 6y is equal to 18. Collect your like terms. 12y plus 6y is 18y minus 72 is equal to 18. We're going to add the 72 to the other side. So 18 plus 72 is 90. Divide both sides by 18, and y is equal to 5. Now we're going to take that 5 right here, and we're going to go substitute it into a place where y is at. I'm going to substitute it right down there because I want to know what x is. So that would be the best place. 4, but where the y is, I put in 5 minus 24. So I get 20 minus 24, which is negative 4. Writing that as an ordered pair is x, comma, y. If you need more practice on solving systems of equations using the substitution method, be sure to check out my teaching video on this topic. If you found this video helpful, please like and subscribe to my channel. This allows me to continue to grow the channel so that I can put out more videos and I can help build your math esteem one problem at a time. See you later.